Chemistry, an introduction to chemical reactions. Forming ionic compounds. Ion. What is an ion? When an atom gains or loses electrons, it becomes charged. An atom that has become charged because it lost or gained an electron is called an ion. If an atom loses an electron, it becomes positively charged and is called a cation. If an atom gains an electron, it becomes negatively charged and is called an anion. But what determines if an element gains or loses an electron? The periodic table provides us with the name of each element and the number of protons found in an element, which equals the number of electrons. Electrons can be found orbiting the nucleus of the atom in shells or orbitals. All atoms want to have a stable outer orbital, meaning the orbital has the maximum number of valence electrons. They all want to have the same configuration as noble gases, which are very unreactive. The periodic table provides us with the name of each element and the number of protons, which equals the number of electrons. To do this, they will either lose or gain electrons, whichever requires the least amount of energy. To do this, they join with another atom from a different element. But sometimes it can be the same element and either give, gain, or share electrons to become an ion. The information provided on the periodic table helps chemists know what will happen. So the periodic table provides clues to us to help determine which atoms gives up, or gains electrons. What determines if an element gains or loses electrons? Let's dive right in. Each element in the same group or column have the same number of electrons in its outer valence shell. For example, lithium has 1 valence electron. Sodium has 1 valence electron. Potassium has 1 valence electron. What is a valence electron, you ask? The valence shell is the outermost shell of each atom. Here is a Bohr-Rutherford diagram for lithium. We can see that it has an atomic number of 3. This means that there are 3 electrons. The first shell can only hold 2 electrons. Then the outside shell, the valence shell, has 1 electron. Since lithium has 1 valence electron, if it were to give up this electron, there would now be 3 protons and 2 electrons, giving an overall charge of +1. It could also gain 7 valence electrons, giving it a total of 8. But what would require more energy? It's easier for lithium to give up 1 than to gain 7. And that's what will happen. So as an ion, it now has 1 more proton than electron, so it has a +1 charge. And we write that as lithium +1. This means that lithium has an electron to share with another element so that it can give it up. But who wants to share with lithium? Let's go back to our periodic table. Since lithium is a metal, let's look for a non-metal. And we will look at group 7, VII in Roman numerals. And that is chlorine. So we are now going to take a look. In shell 1, it has 2 electrons. In shell 2, it has 8 electrons. And in shell 3, it only has 7 electrons. So it needs 1 more electron to be stable because its atomic number is 17. If I were to draw a Bohr-Rutherford diagram, you would see that the inner orbital is full of 2. The second orbital or shell is 8, and the third is 7. So it has a spot for 1 more. Chlorine has 7 valence electrons, so needs 1 more to achieve stable configuration, which is 8 valence electrons. Ionic bonding. Lithium has a +1 charge, which means that it can lose an electron. Chlorine has a -1 charge because it needs to gain an electron. They can join together, form a bond, and this would then become an ionic compound. Let's take a look. Lithium. Notice that there is 1 electron in the outer orbit or shell, orbital or shell. Chlorine has 7 valence electrons. So what will happen is that lithium will lose the 1 electron, and chlorine will gain that electron. So what is this reaction? Lithium plus chlorine produces lithium chloride. We would write the chemical equation as Li plus Cl produces LiCl. Lithium, Li, chlorine, Cl, lithium chloride. Ionic bonding. Here are the rules to follow when naming binary ionic compounds. The first part of the name always identifies the positive ion, which is the metal cation. This part of the name will be the name of the metal. The second part of the name also identifies the negative ion, which is the non-metal ion. The name of the non-metal ion always ends in the suffix IDE when naming the compound. Name these ionic components. Elements in the ionic compound: magnesium and phosphorus. So what is the name? Magnesium phosphide. Sodium and chlorine. What is the name? Sodium chloride. Calcium and bromine. What is the name? Calcium bromide. Aluminum and oxygen. What is the name? Aluminum oxide. Determining the chemical formulas for binary ionic compounds. To write the chemical formula for an ionic compound, you will use the ratio of the ions that make up the compound. First, determine the chemical formula for an ionic compound based on the number of the compound, knowledge of the valence electron for each atom, and the ion charge that each atom forms. Since ionic compounds are neutral, the sum of the positive and negative charges from the ions must be zero. Therefore, the correct ratio of ions must be determined so that the net charge of the compound is zero. Let's take a closer look. Here's an example. We have aluminum fluoride, magnesium nitride. First, we identify each ion and its charge. So aluminum is Al, and from the periodic table, we know the charge is 3+. Fluoride is F-. For magnesium nitride, magnesium is Mg2+, nitride is N3-. Next, determine the total positive charges and the total negative charges needed to equal 0. Well, for aluminum, we found it was +3. And for fluoride, it has to then be -3, as 3+ and 3- is equal to 0. For magnesium, it's 2+, nitrogen is 3-, so we have to cross multiply and we will get 3 times 2+ is 6+, 2 times 3- is -6, or 6-. 6+ plus 6- is 0. So from this, note the ratio of cations or cations to anions. Al 3+, so we need 3F-. We have 3 magnesium 2+, 2 nitrogen 3+. From there, we will write these values as subscripts. So aluminum fluoride has the formula AlF3. Magnesium nitride is Mg3N2. Names bond, ionic bond, taken, not shared.